In this video, we're going to take a look at a bunch of examples that involve factoring out the greatest common factor. So looking at the first example, and this is generally true for a lot of examples, we have kind of two parts that are going to be involved in the greatest common factor. The numbers in front are called the coefficients, and for the coefficients I can factor out the largest number that divides all of them. For the variable parts of the expression, I'm going to determine what the greatest common factor is by looking at the exponents. The exponents basically represent how many times that variable appears as a factor. And so we're going to use the smallest exponent for each of the variables. We're going to use the smallest exponent to determine the greatest common factor. So let's take a look at this. So you may notice that if we look at the three terms in the expression, all three numbers are divisible by 5. So 5 is the greatest common factor. I should say, and it turns out that 5 is the greatest common factor. We'll see why in a moment. For the x term, if I look at the exponents, I have x to the 5th, x squared, and x to the 3rd power. And so x squared is the smallest of those exponents. So x squared means x times x. X to the 5th means x times x times x times x times x. And so there are certainly, x appears at least 2 times in each of those terms. For the y variable, I have an exponent of 2, an exponent of 3, and then when y appears by itself without an exponent explicitly written there, it means that it's raised to the 1st power. So that would indicate the smallest exponent, and so I can just take one y from each of those terms. So then to complete the factorization, I need to identify what's left behind. So in the first example, if I factor out a 5, 10 is 5 times 2, so there's a 2 left behind. We factored out 2 of the x's. There were 5 x's altogether, so that means there are 3 left. We factored out 1 y, and so there's 1 y left. In the second term, dividing 15 by 5 gives me 3. So if I factor out a 5, there's a 3 left behind. We took away both of the x's, so there aren't any x's. There were 3 y's, and we took away one of them, so there are 2 left behind. So the y cubed, if I take out that 1 y, I'm left with 2 y's are left behind. And then finally, 5, of course, if I factor that out, it goes to the front. The minus sign, because I took away a positive 5, there's still a minus sign left behind, so I can kind of think of that as like a -1 times 5, so there's still that -1 left behind. And there's 1x left behind because I took away x squared, so x cubed had 3 x's, so there's 1x left behind. And that's it, because we took away the y. So in general, for these sorts of problems, we can check by multiplying. So this is the factorization. We can always try to check our work by multiplying back out. I know that there's nothing else that can factor from this because 2, 3, and -1 don't have any factors in common. Right? So I know that 5 is the greatest common factor of the number part, and there's no variable that appears in all 3 terms. Right? So there's no x in the middle term, there's no y in the last term. So I've taken out the greatest common factor. To see that this answer makes sense, if we multiplied it back out, I would get 5 times 2. Right? So if I multiply the first term with 5x squared times y, I get 5 times 2 is 10. X squared times x to the 3rd is x to the 5th. Y times y is y squared. With the next term, 5 times 3 is 15. X squared just becomes the x squared of that term, and y times y squared is y cubed. And then finally with the last term, -1 times 5 is -5. x times x squared is x cubed, and then finally the y would be part of that last term. So the next example is kind of similar. We only have one variable to worry about in this example. The numbers in front, though, are a little bit more complicated in a way because we have fractions there. But notice that among the denominators, we just have one denominator. So there's a common denominator, and so I can think of that, that denominator, it indicates that 1/6 is a common factor. And so I could think about the numerators for a second. 5, 7, and 1, those numbers, 5, 7, and 1, they don't have anything in common. And so actually 1/6 is the only number factor, the only factor of the coefficient that's common. So that's going to be part of my answer. I'm going to leave a little bit of space for the x part, for the variable part of the expression. But then let's just kind of see what's left behind. So if I factor out a 1/6 from the first term, 5/6 is actually the same as 5 times 1/6. And we can see that if you think about the following idea, 1/6 times 5, that's the same as 1/6 times 5/1. Because if I want to turn 5 into a fraction, I can simply turn it into a fraction by writing 1 as the denominator. And then multiplication would be 5 times 1 gives me 5, and 6 times 1 gives me 6. So multiplying this back out, 1/6 times 5 is 5/6. In a similar way, 1/6 times 7 gives me 7/6, and then the last two terms are just 1/6. So let's think about the variable part. The smallest exponent, looking at the exponents, is 5. So that means I can factor out an x to the 5th, and we can think about what's left behind. So x to the 10th, if there are 10 x's, and I take away 5 of them, there are 5 x's left. And then we get a plus 7x to the 4th. Because if I have 9 x's, and I take away 5 of them, there are 4 left. Plus x squared, because if there are 7 x's and I take away 5, there are 2 left. And finally, this last term is exactly the same as the greatest common factor. So I've taken away everything. So kind of factoring that out, it takes away everything. So I need to put a plus 1 as a placeholder to make it equivalent to the original expression. So the factored form of example 2 is this. 1/6 times x to the 5th times, and then in parentheses, 5x to the 5th plus 7x to the 4th plus x squared plus 1. In this last example, notice that the common factor is a little bit more complicated. I have x squared times the quantity x plus 2, and then plus 5 times the quantity x plus 2. So we can kind of think of those two things, those separate things, as separate terms. And the factor that's common between those two terms is the x plus 2. So x plus 2 is the common factor. So if I factor that out, let's think about what's left behind. The first group has x plus 2 times x squared, and the second group has x plus 2 times 5. And so what's left behind is x squared plus 5. So this would be a factorization of that expression, of the upper expression. Well, I encourage you to take a few minutes, pause the video, and try the following problems. Try to factor out the greatest common factors of these two expressions. In just a moment, I'll work through the answers, but I encourage you to pause the video and try to come up with the answers on your own first, and then check your work by watching the end of the video. I hope you took a few minutes to try to work out the answer to these problems. Let me just kind of walk through what the answer is. So in the first example, 7 divides, it turns out 7 divides each of those numbers. there's only one a in the last term, so that's the most number of a's. And b cubed is also part of that last term. So then what's left behind is a to the 8th times b to the 4th. Right, we factored out the 7. We took away one a, that left 8 behind, and we took away 3 b's. The second term is 5a to the 6th, b to the 3rd power. Since I took away 3 b's, there were 3 left. And minus 3. And then we took away both of the a's, both the a and the b cubed, and so that's it. So that would be the factorization of the first expression. The second one is similar to that third example from before. So we have 6m minus 7 is common. So if I factor that to the front, 6m minus 7, then what's left behind from the first two things, right? So kind of across this minus sign, in front of that minus sign I have 6m minus 7 times 4m cubed. So I'm going to separate that with a parenthesis. And then behind that minus sign, well, there's just 6m minus 7. But I can think of that as negative 1. Because of the minus sign, I can think of that as negative 1 times 6m minus 7. And so then to kind of create a placeholder that would make this equivalent, I would put a minus 1 at the end. So the 6m minus 7, to kind of think about our answer and check our work, 6m minus 7, if I multiply it back out, it gets multiplied times 4m cubed. It gets multiplied times 4m cubed, and then also times negative 1. And so the factored answer would be that. I hope you enjoyed the video. Thanks for watching.